Hi everyone, and welcome to first edition of SwiftCraft conference. I'm Araks Avoyan, and today I'm going to talk about the art of functional state management. I'm senior iOS engineer currently in Bambuser, and in my whole experience, I worked in different type of companies, starting from outsourcing to startups, big and small product companies. And I want to share some approaches that can help you write cleaner, more predictable, and easier to maintain code. Do you ever feel like your iOS app state management is a tangled mess and it's struggling to keep track of changing data and ensure your UI updates are always in sync? I think we've all been there. Managing your app state can be difficult and quickly become a complex web of code, making it difficult to reason about and maintain. And one approach we'll explore is functional programming. Functional programming focuses on building programs from pure functions and immutable data. This focus on immutability makes your code more predictable and easier to test. We'll also delve into reactive programming, a paradigm for handling data streams and UI updates in a declarative way. We will see how frameworks like Combine leverage these principles to provide a practical solution for state management. And we'll delve into some hands-on examples finally, and we'll compare traditional state management approaches with functional and reactive approaches that we've discussed. And let's start with functional programming fundamentals. Let's delve into the core principles of functional programming that make it a powerful tool for state management in iOS apps. One of the core concepts introduced in functional programming is immutability. Imagine building a house of cards. When looking through it through the lens of functional programming, adding a new card, it creates a new structure and is not modifying the existing one. This concept of immutability is a core principle in functional programming. In state management, it means we don't directly modify our data. Instead, we create a new state object with the desired changes. This eliminates the risk of accidentally mutating the data and causing unexpected behavior. So our data is immutable, so new state objects for updates. Here's a simple example. In the traditional approach, we directly modify the tasks array. In the functional approach, the add task function, it creates new array with the updated data and leaving the original task array untouched. Another key concept is pure functions. These functions always produce the same output for a given input without any side effects. They don't modify our global state or interact with external resources. This makes them predictable and easier to test. So consistent output for same input, no side effects. Here's some example. Here, the traditional update task function modifies the global tasks array, making it an impure function. The functional approach creates a new copy of an array with the update, ensuring consistency and avoiding side effects. By using the immutability and pure functions, functional programming offers several advantages for state management in iOS apps. With immutable state, you are less likely to introduce bugs by accidentally modifying data. Pure functions make reasoning about code easier, as the output is always consistent for a given input. Additionally, functional code tends to be more modular and easier to test in isolation. While functional programming has its benefits, it's important to acknowledge some potential drawbacks. Learning functional programming concepts might require some initial investment, especially for developers without prior experience. And additionally, expressing complex logic with pure functions can sometimes lead to more lines of code compared to interactive approaches. However, the benefits in terms of code maintainability and predictability often outweigh these drawbacks. Second, let's look at reactive programming. And it's a powerful paradigm for managing data streams and keeping your UI in sync with changes in your iOS app. So what's the reactive programming? It's streams for responsive UIs. Imagine data flowing through your app like a river. Reactive programming treats this data as streams of events, allowing you to react changes in a declarative and efficient way. UI elements become like ripples on the surface of the river, automatically responding to the flowing data. Reactive programming has several key principles that make it well suited for state management in iOS apps. First is declarative approach. Instead of writing step-by-step instructions on how to update UI, you describe how the UI should respond to changes in the data. This makes the code more concise and easier to reason about. Second is data streams. Imagine a stream of native data arriving in chunks or user interaction events happening one at a time. Reactive programming allows you to process these events efficiently as they occur. Unlike traditional approaches that rely on polling for updates, reactive programming is event-driven. Your app reacts to specific events, changes in data streams, triggered by user interaction, network requests, or other events. This leads to a more responsive and efficient user experience. Example: for instance, user taps a button, which is an event, which triggers a network request, another event. The response from the network request becomes an event that updates the UI through the data stream. This eliminates the need for constant polling and makes the app more responsive to user interactions. By using these core principles, reactive programming offers several advantages for state management. Declarative approach simplifies UI updates, while treating data as streams allows for efficient transformations and filtering. Additionally, the event-driven nature promotes a more responsive app that reacts to user actions and data changes immediately. While reactive programming has its merits, there are some potential challenges to consider. Understanding core concepts like publishers, subscribers, and operators may require some initial investment in learning. Additionally, debugging issues within complex data streams can be more challenging compared to traditional approaches. Visualizing and tracing the flow of the events might require additional effort. And let's look into Combine, Apple's framework for reactive programming for iOS. Combine empowers you to manage state in a functional and declarative way. Combine is a powerful framework built into Swift that uses the principles of reactive programming. It provides a way to define data streams, publishers, that emit values over time and allows you to track those changes using subscribers. Imagine a stream of events flowing through your app. Combine allows you to define what events are emitted, which are publishers, and how different parts of your app react to those events, which are subscribers. This approach promotes a more declarative and reactive way to manage your app's state. Combine offers several key functionalities that make it ideal for state management. Think of a publisher as a source of data, like a newsfeed that emits new articles. Subscribers are like readers who react to the new articles being published. In our state management context, the publisher should be a state object that emits updates whenever the state changes. And the subscriber could be a UI element that updates itself based on the new state. Combine provides a rich set of operators that allow you to transform and manipulate data. You can use operators like map to transform values, filter to select specific events, or combine latest to merge multiple streams. These operators enable you to build complex data flows in a modular and declarative way. Here's a simple example. We defined a current value object, value subject publisher that emits integer values. We then use map operator to transform the integer into string for display. Finally, we use the assign_to method to bind the data stream to the text property of a label. Then we call send10. The publisher emits a new value, which is a state change, and the label text automatically updates to 10 due to the binding. Combine excels at handling asynchronous operation and error management within your state management logic. Imagine a network request that updates your app state upon successful completion. Combine allows you to integrate this asynchronous operation within your data. Additionally, Combine provides a built-in error handling mechanism to gracefully handle potential errors during data processing or network requests. By using Combine, you gain several advantages in your state management approach. The declarative nature of Combine simplifies UI updates, as UI elements quickly react to changes in data stream. Additionally, Combine integrates asynchronous operations seamlessly within your state management logic. Furthermore, Combine provides built-in error handling and cancellation mechanisms, leading to more robust and maintainable applications. While Combine offers significant benefits, there are some potential considerations. Since it's your framework, we have limited resources or libraries compared to more established approaches. Let's see the power of Combine through a practical example. We'll build a simple counter app and compare how we manage state traditionally. For us, we will use MVVM and with Combine. In traditional MVVM approach, we typically have a view model responsible for managing the app state and exposing observable properties for a view to bind to. We might also have separate methods for incrementing and decrementing the counter. Here we have counter view model with an in property for the count and methods to increment and decrement. The counter view controller holds a reference to the view model and binds the counter labeled next to the counter property. Button taps trigger the view model's methods. It updates the counts and then manually updates the label text in view controller. With Combine, we can manage the state in a more declarative way. We can define a publisher that emits the current count and use operators to react to changes. The view can directly subscribe to this data stream and update itself automatically. Here we are, the counter view model uses the publish property wrapper to create a publisher that emits the current count whenever it changes. The button taps still trigger the increment and decrement methods, but the view controller now subscribes to the count property stream using the assign to method. This automatically updates the label text whenever a new value is emitted by the publisher. This example highlights the benefits of using Combine for state management. Its declarative UI updates. The view directly subscribes to the data streams and updates automatically. It eliminates the need for manual updates in view controller. And it improves the readability. The code becomes more concise and easier to reason about as the data flow is more explicit. Let's see the power of Combine through let's see how Combine tackles a slightly more complex scenario, managing a user profile with a network request to fetch user data. We'll compare the MVVM approach and the Combine approach. In a traditional approach, we might have separate view model for the user profile and the network service responsible for fetching the data. The user profile view model holds properties for user information and method to fetch the data from the network service. The view would bind to these properties and potentially trigger the data fetch action. Here, the user view model has properties for user data and the reference to the network service for fetching data. The fetch user profile method triggers the network request using a completion handler. The completion handler updates the view model properties, but manually notifying the view about these changes might be required, for example, using delegates or closures. And when we are calling fetch user profile from view controller using this user view model, we will need to implement this delegate or closure, so we'll need to have one more step to update our view. With Combine, we can model the user profile data as a publisher and use operators to handle the network request and update UI declaratively. Here, the user, we have the same network service, user, and user data, which will be a model that we will use from our network service. Here, the user view model uses the published property wrapper to create a publisher for the user data. We inject a network service that returns a publisher of user data or an error. Upon initialization, we subscribe to the network service publishers. The subscription closure handles the following: data transformation. The closure uses the map operator to transform the incoming user data, which is a response from the network, into a user object. This might involve extracting the relevant data like first name and last name from the network response. Secondly, it's error handling. The closure also handles potential errors using the sync operator. The sync operator provides completion and value callbacks. We can use the completion handler to check for errors and potentially display an alert or handle the error gracefully in the view model. And also, we are assigning the updated value. Once the data is transformed, the closure assigns the new user object to the user property. Important to note that we also can utilize storing cancellables to manage subscription lifecycle and prevent memory leaks. This is essential when dealing with subscriptions in Combine. By using these operators and the published property wrapper, Combine enables a more declarative and reactive approach to data flow and UI updates in our view model. Let's recap the key takeaways from today's exploration of functional programming, reactive programming, and their application to state management in iOS apps. We see how functional programming principles like immutability and pure functions can lead to more predictable and maintainable code. We also saw how reactive programming allows us to manage data streams and UI updates in a declarative way, simplifying how our apps react to changes. Finally, we introduced Combine as a framework that embraces this concept and provides a powerful toolkit for state management in iOS development. Explore other frameworks for reactive and functional programming is not only Combine out there. I understand that you need to think twice before adding a third-party library and you should be cautious, but just experiment and test. Does it work for your use case? Don't be afraid to try new tools. Explore other libraries to find the best fit for your project. There are many resources available online to help deepen your understanding. Try balance efficiency with simplicity. While frameworks like Combine can streamline development, avoid over-engineering. There are cases where simpler solutions are more suitable. Don't try to over-engineer something just for the sake of using it. There will be cases, and a lot of them, that just adding Combine will make things complex, non-readable, and an overkill for the project. For some cases, using similar library will unlock for you so many new ways of development. That was what was my experience. Just for example, whenever I was having repetitive kind of screens, let's say sign up flow. Each screen has kind of same text field for different parameters. Let's say one screen for a name, another one for age and email. In those cases, just creating once the structure of emitting the event and handling the actions, creating this strategy, it makes development of new screens considerably easy. And the most important thing is enjoy the process. Engineering should be fun. If it's not, then pivot. Explore alternative code strategies. Thank you for your time. If you have any questions, feel free to reach out to me here or afterwards. And I hope you'll enjoy the rest of the conference.